All right, this lesson deals with expected values. Now, this is an interesting lesson in that it kind of takes the idea of probability and associates it with money, or the value that could be associated with some sort of game or activity. Okay, and this is how you can base whether or not to gamble on something. And I'm not saying that you should ever gamble on something, but this is how you determine what you're going to expect to win or lose. Okay, so let's take a look at what an expected value is. Expected value is an application of probability which involves the likelihood of a gain or a loss. In other words, are you going to gain some money or lose some money? It's relevant for business, insurance, and many situations in daily lives. There's many times where we use expected value and you probably don't even know you're using it. Okay, you'll learn how to use probabilities to calculate whether you can expect a gain or a loss in a mathematical situation. The gain or loss associated with each event is known as the payout. In many games, you pay to play and you hope to win some money. You hope to receive a payout. But is the game worth playing? That's the big question. Is the game worth playing? Okay, does the amount you could win sound too good to be true? So there's a formula, and I think you should have this on your cheat sheet. Expected value is calculated by taking the probability of winning the game and multiplying it by how much you would win. So we'll put the dollars you would win, and then we subtract the probability of losing with how much you would lose. Okay? If you play a game with an expected value that is less than 0, you can expect to lose money. If you play a game with an expected value that equals 0, you can expect to break even. And if you play a game where the expected value is more than 0, you can expect to gain money. So let's take a look at an example. A game has 5 cards. Whenever I see stuff like this, I always think of the Red River X. I don't know if guys have been to the X or to a fair where they have these guys trying to get you to convince you to play the games to win the teddy bear or whatever it is. This is kind of these types of games. So a game has 5 cards. Okay, so picture 5 cards, and one of them you're going to win. Now you don't know what they are, so that's the problem. The game costs $1 to play. If you select the correct card, you win $4. Can you expect to make money if you play this game? So, you walk up to this game, you pay $1, you have a chance to win 4. Sounds pretty good, you're going to come out way ahead if you win. Now the question is, what is the expected value? If you played this game over and over again, what are your chances of winning? Well, your expected value, if you look at that formula up there, is the probability of winning times how much you would win take away the probability of lose times how much you would lose. So let's fill in the blanks. What is the probability of winning here? Well, there is one favorable outcome, so the probability of winning is 1 out of 5. How much do you win? Now some of you are saying 4. It's not. It's $3. Why is it only 3? Because you pay 1, win 4. So you're only up 3 if you win. If you win. Now what is the probability of losing? It's 4 out of 5. If the probability of winning is 1 out of 5, the probability of losing is 4 out of 5. And how much would you lose? Well, you would just lose the $1 that you paid to play. Okay, so you grab your calculators here. You're going to go 1/5. Now 1/5 is 1 divided by 5 times 3. Okay, so try that. This is going to give you 0.6 minus 0.8, which gives you negative 0.2. Now what does that mean? This is the expected value. If you play this over and over again, you can expect to lose. You can expect to lose $0.2 each time, which is 20 cents. Now obviously you're not going to lose 20 cents. You're going to lose either $1 or you're going to gain 3. But if you do this repeatedly, this is what you would expect to lose each time, on average. Okay, so let's try another expected value question. Why don't you guys try this one? Write out the formula. Okay. So, based on past experience, a building contractor estimates that the probability of winning a contract, in other words, getting the job, is 0.3. That's the probability of winning. That means the probability of losing is 0.7. Okay? The contract is worth $25,000. Okay? And she knows it will cost $2,400. So how much would you end up winning? Well, you would win $25,000, but it cost you $2,400. So that means this would be $22,600. Okay, now what does it cost? What do you lose? Well, you still have this amount. That's what you would lose because you'd prepare the contract even if you didn't get it. Okay, so grab your calculators. You're going to go 0.3 times 22,600, take away 0.7 times 2,400. If you put this in the calculator, you end up with 5,100. Okay, so that's pretty good. This tells me that the expected value is $5,000. Okay, in this case, the expected value is greater than 0. Okay, that's good. So, what's her name? It doesn't say. So, the contractor should bid on the contract. Doesn't mean they're going to win, but if they do this over and over and over again, yes, they're going to lose $2,400 sometimes, but the ones that they win make it so that your expected value is $5,100 each time. Okay? Now, so this is A. B, that's B. C, it says, what other factors might you consider in making this bid, or whether to do it or not? Well, you might consider how much staff you have available. You know, you might decide not to bid on a contract if you have no staff available. Okay. Do you have the time to do the job? Is it a good job? Like, do you really want to have this job from this company? Is the reputation good? Okay, there are other things that might influence your decision making. But obviously making money is probably the one that's one of the main ones. Okay, example 3. A farmer is deciding whether it is worthwhile to grow a mixed grain crop in one of his fields. He knows from experience that he will be able to harvest a crop 8 years out of 10. So that's your probability. Seeding, fertilizing, and harvesting costs him $200 per acre. He estimates the revenue from a good harvest to be $350 per acre. Should he continue growing crops on his field? How much money will he make or lose if he's farming a 160-acre field? Okay, so let's write out our formula. Expected value. This is the probability. Well, I guess we're not going to say win this time, right? I mean, I'll write the probability of win, but what is the win this time? The win is harvesting a crop. Okay, the probability of lose is not harvesting a crop. So keep this in mind, that is your winning and losing. So the probability of winning is 8 out of 10. The probability of losing is 2 out of 10. Okay, now we have to figure out how much would you win. It says that the costs associated are $200, but you make $350. So you would win $150 here. Okay, that's $350, take away $200. What would you lose? If you don't harvest a crop, you're just going to put in the $200 and you're going to lose that. Okay, so the expected value, well, we go 8/10. This is 120 minus 100. This is $20. $20. What? Oh, sorry, not 20. I made a mistake there. This is not 100. This is 40. So I get 80. What does this mean? So that means there's an expected value of $80 per acre. Okay. If the farmer has 160 acres, the farmer would expect to make $80 times 160, which is $12,800 per year. Okay, now some years he's going to lose money, but other years he's going to make more. This is what you would expect on average to make each year. Okay, so that's expected value. If you guys could do this assignment, that would be great. There's your answers. We'll do the test review in class together.